Bismillahirrahmanirrahim. Assalamu alaikum students. This is Hamza Noor, and in this particular video I'm going to solve the question number 7 of International A-Level Edexcel P3 January 2022 paper. So here we have a graph. Figure 2 shows a sketch of part of the graph with equation y is equals to fx, where fx is equals to half multiplied by modulus of 2x plus 7 and then minus 10. So the requirement of part A is to state the coordinates of the vertex V of the graph. As we can see, point V is over here. So as you know the fact that at point V, the function will have a least value. Okay, and if you just compare it with just the graph of the modulus of x, as you can see, the multiple transformations have been combined over here. And what I'm trying to tell you is that the graph has been vertically translated 10 units downwards. Okay, so obviously this least value would be minus 10. All right, it is the least value of the function. So what we need to do, we need to keep the function equals to minus 10 in order to find the corresponding x coordinate of the point V. All right, so when the whole function will be kept equals to minus 10. All right, so what's going to happen? Minus 10 is equals to half multiplied by modulus of 2x plus 7 and then minus 10. So therefore we can say that minus 10 and minus 10 is cancelled out, and therefore half multiplied by modulus of 2x plus 7 will be equal to 0. So all you need to do is just solve this equation that modulus of 2x plus 7 is equal to 0. Therefore 2x plus 7 is equal to 0. X is equal to minus 7 over 2. So therefore we can say that the coordinates of V are minus 7 over 2 comma minus 10. As simple as that. This is supposed to be your answer to part A. And alternatively, if you want to avoid this working, which I've done, all you can do is just equate this 2x plus 7 in the mod function, which you can see over here in the original function. You can equate this 2x plus 7 with 0. All you need to do is just perform this step. But in order to give you a detailed explanation, I've done some extra working as well. All right, so you will get complete marks when you will state the coordinates of V in the form of x comma y. So at this point, x is equal to minus 7 over 2. The least value of the function will occur, which is minus 10. As you can see over here, since the multiple transformations are applied to the graph of y is equal to modulus of x. Okay, so now let's move on to part B on the next page. All right, so part B says that solve using algebra this inequality half multiplied by modulus of 2x plus 7 and then minus 10. This is greater than or equals to 1 over 3 times x plus 1. All right, we need to solve this inequality. In order to solve this inequality, first I'm going to rearrange it into a specific form. So half multiplied by modulus of 2x plus 7 is greater than or equals to x over 3 plus 1 plus 10. Okay, so I have moved that minus 10 constant term on the right hand side of the inequality. So now I can say that half multiplied by modulus of 2x plus 7 is greater than or equals to x over 3 plus 11. So now we can say that the modulus of 2x plus 7 is greater than or equals to 2 is completely multiplied by x over 3 plus 11. So now we can say that the modulus of 2x plus 7 is greater than or equals to 2x over 3 plus 22. So now I have arranged this inequality in a particular form where I have a modulus function on the left hand side of the inequality and a linear function on the right hand side of the inequality, which is without the modulus. Okay, so in order to solve this further, in order to solve this inequality, when the modulus sign will be removed, so you can say that 2x plus 7 is greater than or equals to plus minus completely multiplied by 2x over 3 plus 22. So in order to solve this inequality, first case you have is 2x plus 7 is greater than or equals to 2x over 3 plus 22. First of all, you will solve this inequality, and you will also have a second case where 2x plus 7 is less than or equals to minus 2x over 3 minus 22. Since the minus sign is multiplied on the right hand side of the inequality, the sign of the inequality will change. So here we have case number 1, and here we have case number 2. Okay, so first of all, I'm going to solve the case number 1. So 2x minus 2x over 3 is greater than or equals to 22 minus 7. So therefore I can say that 4x over 3 is greater than or equals to 15. Therefore we can say that x is greater than or equals to 15 times 3 divided by 4. So 15 times 3 is basically 45. So x is greater than or equals to 45 over 4. And then we have another case. This was case number 1. All right. And now we have case number 2. And according to case number 2, 2x plus 7 is less than or equals to minus 2 over 3 into x minus 22. So therefore we can say that 2x plus 2x over 3 is less than or equals to minus 22 minus 7. So far we have achieved this thing. So 2 plus 2 over 3, this is supposed to be 8 over 3. So 8x over 3 is less than or equals to minus 29. So therefore we can say that x is less than or equals to minus 29 times 3 divided by 8. So therefore we can say that x is less than or equals to minus 87 over 8. But here you need to make sure that both of the inequalities are valid, since we are dealing with such a case that where we have a modulus function on one side of the inequality and we have just a straight line linear function which is without modulus on the other side of the inequality. So this means that if I sketch the graph of 1 over 3 times x plus 1 on the earlier page, and as I know the fact that this whole function is basically fx, and fx is already sketched on the earlier page. Okay, so all I need to do is just sketch 1 over 3 times x plus 1 over here. So we will have an upward sloping line which will have a vertical intercept of 1 and slope will be 1 over 3. Okay, so I'm just making a rough sketch over here. As we can see that we would have 2 points of intersection. So in this case, as we can see that both of the inequalities are valid. So therefore, our answer would be that x is greater than or equals to 45 over 4, x is less than or equals to minus 87 over 8. So therefore, we can say that the final answer is that x is less than or equals to minus 87 over 8, comma, x is greater than or equals to 45 over 4. This is supposed to be our final answer to part B. So alternatively, what you can do over here is that you can use the sketch of the graph on the earlier page, and here we can make two separate cases. As you know the fact that here we have a positive x coordinate, okay, and here we have a negative x coordinate. So in order to find this positive x coordinate at this particular point, the slope of the modulus graph and slope of the linear function, which is without the modulus, both slopes are positive. Okay, so in this case, we would say that half multiplied by 2x plus 7 minus 10, this will be equals to x over 3 plus 1. Since the slope of the modulus graph will be positive, therefore I have mentioned 2x plus 7. So if you solve this equation, you will get the value x is equals to 45 over 4. So I'm not showing the completed steps. You can do it yourself. I'm just trying to explain you the alternative approach. So now in order to find this negative x coordinate, as we know the fact that at this particular point, the graph of the modulus function is downward sloping. So it will have a gradient which is negative. Okay. And the upward sloping straight line will have a positive slope. So therefore, we are going to say that half multiplied by minus sign is multiplied by 2x plus 7 completely, and then minus 10, and this whole thing will be equals to x over 3 and then plus 1. All right, so this will be half is completely multiplied by minus 2x minus 7 and then minus 10, and this whole thing will be equals to x over 3 and then plus 1. And when you will solve this equation, you will get x is equals to minus 87 over 8. Okay, so I'm not showing the complete steps. You will do it yourself. You will obtain x is equals to minus 87 over 8. So this means that when you solve the equation, one root is x is equals to 45 over 4, and the other root is x is equals to minus 87 over 8. But since we are solving the inequality, and the inequality is like this, that half multiplied by modulus of 2x plus 7 and then minus 10, this whole thing is greater than or equals to x over 3 plus 1. And as we know the fact that we have the graph of the modulus function, which is fx, so therefore we are going to say that fx is greater than or equals to x over 3 plus 1. So in order to solve the inequality, we need to find the critical region. So we will shade the part of the graph for which the fx function is greater than or equals to x over 3 plus 1. Okay, we are going to shade the part at which the fx graph has higher values as compared to the graph which is an upward sloping straight line. So if I extend this graph of fx, so I can shade this particular part at this region. As you can see that the fx graph will have higher values as compared to the green upward sloping line, and here I would shade this particular region. In this particular region, as we can see that fx graph will have higher values as compared to this green upward sloping straight line. So therefore we can say that the inequality is that x is greater than or equals to 45 over 4, comma, x is less than or equals to minus 87 over 8. So this is basically the alternative approach to attempt part B. This is supposed to be your final answer. So now let's move on to part C. So I'm going to erase the working of part B completely, and I'm going to solve part C on this same page. All right. So in part C, you are required to sketch the graph with equation y is equals to modulus of fx, stating the coordinates of the local maximum point and each local minimum point. So on the same page in the available space, I'm going to sketch the graph x-axis, origin, and y-axis. So I'm going to bring the original graph, which was shown in figure 2 on the same page, so we can make a comparison. As we know the fact that we want to sketch the graph of y is equals to modulus of fx. Okay, so in order to sketch the graph of y is equals to modulus of fx, first of all, what you need to do, you need to sketch the graph of y is equals to fx. And for that purpose, I've brought the original sketch figure 2 on this same page, and the parts of the graph which are below the x-axis will be reflected in the x-axis. Okay, so we are going to reflect any parts where fx is less than 0, and we will erase the part of the graph which is below the x-axis. Okay, so if I make a rough sketch using the figure 2, so the graph would be something like this, that the part for fx which is less than 0, which is below the x-axis, this complete part will be reflected in the x-axis. Okay, but since this is a rough sketch, I'm going to make a fair sketch on the space available here. And since the requirement of the question is that to state the coordinates of the local maximum point and each local minimum point as well, so I'm going to mark the points for which you have to tell the coordinates as well. Point number 1, point number 2, and point number 3. All right, and for that purpose, we are going to do some working as well. As we know that fx is equals to half multiplied by modulus of 2x plus 7 and then minus 10. So first of all, we are interested in finding the x-intercepts, and for that purpose, fx will be kept equals to 0. All right. So therefore, we can say that half multiplied by modulus of 2x plus 7 will be equals to positive 10. So therefore, modulus of 2x plus 7 is equals to 20. Therefore, 2x plus 7 will be equals to plus minus 20. Since in order to solve this equation, we have to remove the modulus sign from the left hand side of this equation. So 2x plus 7 is either equals to 20 or 2x plus 7 is equals to minus 20. So x is equals to 20 minus 7 completely over 2. So x is equals to 13 over 2 and x is equals to minus 20 minus 7 completely over 2. X is equals to minus 27 over 2. Okay, so therefore we can say that this coordinate is minus 27 over 2 comma 0, and this coordinate is basically 13 over 2 comma 0. These are the local minimum points. Okay, and now we want to find the local maximum point as well. And as we already know that the answer of part A, the coordinates of the point V were minus 7 over 2 comma minus 10. So now this point V will be reflected in the x-axis. So the y coordinate of point V will change. The x coordinate of point V will remain same. So the local maximum point is supposed to be minus 7 over 2 comma positive 10. So now I'm going to sketch the graph on the space which I have made myself. Okay. So first of all, I'm going to make a line segment like this. Okay. And one of the local minimum points is 13 over 2 comma 0. And then we will have an other line segment which will go up till the point minus 7 over 2 comma 10. Okay, so let's say somewhere over here, this is the local maximum point minus 7 over 2 comma 10. And then we will go up till the second local minimum point, which is minus 27 over 2 comma 0. And now we will have the last segment of the line like this. And you also need to make sure that the slope of this downward sloping line and this downward sloping line looks the same. And you also need to make sure that the slope of this upward sloping line and this upward sloping line looks the same. Otherwise, you are going to lose your marks. So this was answer to part C. It was worth 4 marks. So this was basically the question number 7 of International A-Level Edexcel P3 January 2022 paper.